Okay, so these are the questions that you have given me that I help you. Like question 1 here, given that A is that and B is that, then they're saying A, find the value of Y for which the determinant of A and B are equal. So first of all, you must understand what a determinant of a matrix is. So like determinant, which is represented by D et, which is of a matrix. Let's say matrix A, its determinant can be given by, if you get the values or elements in the what we call major diagonal minus those in the minor diagonal, like 4 and 2 are in the main diagonal. So you say 4 times 2, okay, these in brackets, then minus, then you say 1 times C negative 5, open brackets, 1 times C negative 5. So this is how you get the determinant. So like of this matrix A, so we'll say okay, then it will be equal to, so 4 times 2 it will be 8, then you say minus, then open brackets, you say 1 times 5 it will be negative 5. Then here, since you have minus and minus inside the brackets, so you say minus times minus, it will be positive. Then here you have now 5. So you say now that 8 plus 5, which is going to give you 13. So meaning that the determinant of matrix A, its determinant is this 13 here. Then you also need to find the determinant of matrix B. So that you say determinant of matrix B also will be the subtraction of 8 times 5, like 8 times 5 in the main diagonal minus, then you say 3 times y. So you say open brackets, 3 times y, close brackets. Then you say okay, 8 times 5, which will be 40, okay, then minus here 3 times y, it will be 3y. So I didn't put the brackets here because here I had to maintain the brackets because of that minus here. So now you are told that you should find the value of y for which the determinants of A and B are equal, meaning the determinant of A here, which is 13, is equal to the determinant of B, which is this. So here it has remained like this because we cannot further simplify 40 minus 3y because these are not like terms. So it means if determinant A, determinant of matrix A must be equal to the determinant of matrix B. That's what they mean there. So the determinant of matrix A is 13, so you substitute is equal to the determinant of matrix B is 40. Here you put 40 minus 3y. Then what you're going to do is to make y the subject of the formula. So you can start with this side, which has a 40, okay, minus 3y. Then you swap, you say equals 13. I've just swapped this so that I start with this part which has got the y because they have said find the value of y. So what we are going to do there is this. So you will say that here now what we are going to do is to collect like terms. This is a number and this is a number, so they must be on the right side of the equation. So here you remain with negative 3y is equal to 13. So this 40, when it jumps this other side, it becomes negative 40. Okay, so then you have negative 3y is equal to, so you're saying like 13 minus 40. So it is as good as saying 40 minus what? 13. Okay, so you say okay, 0 minus 3, which is actually, it can't, you get a 1 from here, you put there, so it will be 10 minus 3, which will be actually 7. Then here you remain with 3 actually, so you say 3 minus 1, which is actually going to be 2, so it will be like 27. Now since the bigger number has got a negative here, so it will be negative 27. Then what you're interested in yourself is to find the value of y. So you get rid of negative 3, so you say over negative 3. Even here you say the same over negative 3. So the negative and negative will go, 3 into 3 will go, you remain with y is equal to. So here again, negative will go. So you say 3 into 27, how many times can it go there? Like it should be 9 if not mistaken. So answer here is just going to be 9 like that. So that's how you do it. So that's how you do this one. So I'm going to rub this one and then do the other one. So let me rub this. Let me just increase the size of my rubber. Okay, so okay, then B, they're saying hence find the inverse of B. So now the inverse, so meaning we have found that y is 9. So we'll go per B, we'll write this matrix very well. B is going to be equal to, we have open brackets, we have 8, then 3, where there's y we replace what? 9, then here we'll have 5. So we'll say equals. Now what they want is the inverse, so you need to know how to find the inverse. So the inverse of matrix B is given like this. So inverse, I'll give you the formula which you need to know. So inverse is written like B inverse like this, is going to be equal to, so you say 1 over determinant of matrix B, then times, you get these, you swap them, you put 5 here, then you put 8 here, then you get here, you multiply a negative here and negative here, so it will be negative 3 here and then negative 9 there. That's the formula. So what I've done is I've swapped these elements in the major diagonal, and then I've picked 5 has come here, 8 has come here, then I've multiplied these two with negative. That's how you do it. So we'll get now the determinant. Here we need the determinant of B. So remember, let's first find the determinant of B here. So the determinant of B, which I will say determinant of B, is going to be, I said this times this in the previous one, like 8 times 5, okay, then it will be minus, then we'll say 3 times 9, so open brackets 3 times 9 like that. So it will be equal to, so we'll say 8 times 5, which will be 40, minus 3 times 9, which will be 27, if not mistaken. So say now, okay, 40 minus 40, 27. So get a 1 at here. So 10 minus 7, which will be 3. Then we'll remain with 3 minus 2, which will be 1. So the determinant will be 13. So we know that the determinant here of B is 13. So what we are going to do is to do this. So substitute. So get this same one. We have found the determinant, which is 13. So put 13 here. So say, okay, we'll say inverse then is going to be equal to 1 over, then here we'll put 13, then we'll say open brackets, we'll maintain here 5, negative 9, then negative 3, then 8, then we'll close the brackets. Then what we are going to do is to start multiplying. Then also, okay, the inverse of B is going to be, you multiply this by that. So saying 1 over 13 times 5, it will be 1, it will be actually 1 over 13 times 5, it will be 5 over 13. You do it like that. Then 1 over 13 times 9, it will be negative 9 over 13. Okay, then 1 over 13 times 3, it will be negative 3 over 13. Then you say 1 over 13 times 8, it will be 8 over 13, just like that. Okay, so that will be the final answer here. Then we go to question number 2, I think. This one here, or question number 2 here. So let me also rub everything here so that we do question number 2 here. Okay, so let's go question number 2 quickly there. Let me just clean these things very well so that you see that how to answer these questions. So we will now deal with this part here, which is given that a is that, find the positive value of x for the determinant of a is that. So this would be simple. So like they've given that a is equal to 2x, then 3, then 2, then x, like that. Okay, then they have told you to say a, they're asking you to find the positive value of x for the determinant of a is at top. So they're saying determinant of a, they've given you the actual value, which is 12. Now let's see if the determinant will be 12. So we'll get a is this one. So in reality, let's use this to find the determinant. So remember I told you that the determinant of this a here now, you go to this one, it will be this times this, like 2x times x, okay, like that, then minus 3 times 2, so open brackets 3 times 2, like that. Then you say like that. So what you are going to do, you say 2x times x, it will be 2x squared, because x times x, it should be x squared. Then you say minus, then 3 times 2, it will be 6, like that. Okay, so it means using this, the determinant is this, but in the question they've told you that also the determinant is that. So what you are going to do, it means this, you pick this and this, they are equal. So this and this, they are equal, because the determinant they've given you of a is that, and for you, you have found that the determinant of this is that. So you equate this and this. So you can say, okay, I'll say 2x squared minus 6 is equal to this 12 here. So when you check this one becomes a quadratic equation. So what you're going to do is to do this. If you want, you can collect like terms or bring this one here, so that you have 2x squared minus 6, then this one becomes negative 12, then equals, then you have 0. So since 2 can go throughout these, you can divide everything by 2 first, like that, to make it easy. 2 into 2, it will cancel, you remain with x squared, then minus 2 into 6, 3, then minus again 2 into 12, it will be actually 6, then is equal to 0. Now when solving this quadratic equation of this nature, what we said already earlier on is that if you want, you can look for two numbers which when you multiply them, they'll give you 6, and when you add them, they'll give you 3, because this is a quadratic equation. So look for two numbers which when you multiply them, they'll give you 6, and then when you add them, they'll give you 3. So which are those two numbers which when you multiply them, they will give you this, when you add them, they'll give you this? Okay, so those are the two numbers that we are going to look at. So like here, two numbers which when you multiply them, product, they'll give you negative 6, then when you add them, they'll actually give you the sum or give you -3. So let's look at those two numbers. When you multiply them, they'll give you 6. When you add them, they'll give you that. So let's try. If we say, I hope I've not made a mistake in this one. I'm just trying to confirm. Yeah, so 2, 3, 6. Yeah, so I'll say if I have -2 times positive 3, I'll get a what? I'll get a -6. If I'll say this -2 times, okay, -2 plus 3, I'll just get a 1. So this one is not agreeing, unless I've not made a mistake, because it appears that it is becoming a little bit tricky. Okay, so this times that, it is giving me that 2x squared. This times that 6, then it is equal to 12. Yeah, so I equated this to that, then that is that. I brought this one here, 2 can go in everything, so 2 there, it will cancel, 2 there, 3, 2 there, it will be 6. Then two numbers which, when I multiply them, they will give me the product, which is 6. Then when I add them, they'll give me the sum, which is 3. So these equals 2 okay, it's okay. So this one, it appears it will not like work here. So what we are going to do here, we'll do it like this. So it is not going to work in this format. That's what I've seen. So I'll solve it in this way. It can agree. So, oh yeah, because we don't have xx here. Okay, sorry, I just didn't realize. So it will be x squared. So this one, -3. Okay, I shouldn't even do it up to this level. Sorry, let me just get back here. So when I equate 2x squared minus 6 is equal to 12, so I'll make this one the subject of the formula. So this one will cross the other side. So here will remain with 2x squared is equal to, then 12, then this one will be plus 6. When it crosses, it becomes plus 6. So say 2x squared is equal to 12 plus 6, which will be 18. Okay, so what we are going to do is, to remain with x, we'll say over 2 first, then here over 2. So that one will go, so we'll remain with x squared is equal to 2 into 18, 9. Now when you look at the question, they want the value of x, not x squared. So we'll get rid of the square root. So to get rid of the square root, the square, I mean, or square root this side, and also square root this side. So this and this will go, will remain with x is equal to, the square root of 9 is 3. So meaning this x here is equal to 3. That's how you get it. So that's how you get it. Go through the steps, copy them, and then be able to also answer this one on your own. Try to go through. Okay, then let me wrap so that I have this space for also answering the other part. So let me wrap. Oh, sorry. Okay, so B says hence or otherwise find that inverse. Okay, so we need to find the inverse of A. So A now is going to be equal to, open brackets, what is this now? So say open brackets, where there's x, we have already seen that x is 3, so say 2 times c, that 3, it will give us 6. So here we'll definitely just put 6. Here we have 2, then here we have 3, then here x was found to be 3, so we'll put 3 there. Okay, so here I've put 6 because since we have 2x and x was found to be 3 when we were calculating here, so say 2 times that 3, that's how we got that one. Now on this part it is saying hence find or otherwise find inverse of A. So the inverse, I told you that inverse of A, like we found for B, is going to be equal to 1 over determinant of A, then open brackets, you swap, this one comes here 3, then 6 comes here, then this you multiply negatives there, so you have -3, then here you have -2, like that. This is the formula for the inverse. Then after you do that, what you're going to do is to first find the determinant now of A, where you say, okay, determinant of A is going to be, I said you multiply this times this, so it will be 6 times 3, you put in brackets minus 3 times 2, open brackets 3 times 2, like that. Then you say, okay, 6 times 3, it is going to give you what? To give you 18. Then minus, you say 3 times 2, it will give you 6. So then you say, okay, 18 minus 6, you're going to have 12, right? So 12. So meaning that will be the determinant. So this one is equal to this, meaning where the determinant is, you put 12. So say, okay, therefore, the inverse now of A is going to be 1 over, you put where the determinant is 12, then you open brackets, then you say 3, then here you put -3, then -2, then 6, like that. Okay, then what you're going to do, you do it this way. You say equals, you multiply this times that, you say 1 over 12 times 3, it will be actually 3 over 12. Then 1 over 12 times -2, it will be -2 over 12. Then 1 over 3 times -3, it will be -3 over 12. Then 1 over 12 times 6, it will be 6 over 12. Okay, like that. If you want, you can leave this one here, but since we can still find that 3 into 3 can go there 1, 3 into 12 can go there 4, so you simplify. Then here you say 2 into 2 can go there 1, 2 into 12 can go there 6, so I put a negative there, that negative. Then here you can say 3 into 3, it can go there 1, 3 into 12 can go there 4, and there's a negative here, you put a negative here. Then 6 into 6 can go there 1, 6 into 12 can go there how many times? It can go there 2 times. Okay, so that's what you are going to do. Then you put like this. So this is the determinant or the inverse of A, like that. Okay, then we move on to question number 3. So I've already taught you how to find these. Me answering these questions are just following the same format. So use the same format for you to answer these questions, because it is the same format that they're following. So thank you so much for being patient with me. These are the answers.